Good morning. Good morning to all the students. Very good morning. How are you all today?
Fine, sir.
Okay, there are 59 students who has joined the meeting now. And yes, we continue from our previous session. In the previous section, we have introduction to the course. And at the end of that session, we were discussing about architecture of Arduino, right? Okay, can all of you students see the slides?
Yes, sir.
Yes, sir.
Yes, sir.
So in the previous session, we were discussing about last topic that we were discussing was that architecture of Arduino. Before that, we discussed regarding why should we study computer organization and architecture. Then what are the importance of different specifications of a computer? What are different data representation means? And then finally, we were discussing about this architecture. So whether it is Arduino board or whether it is Intel processor or Atmel processor, any company's processor, what are the architectural components? What are the architectural components? Most of the times, these components will be there. There will always be a ALU, then there will be a timing and control unit, some registers which are connected with the ALU, a flag register, instruction register, stack pointer, program counter. It might be possible that in different microprocessors, the data bus width might change. In this case, it is 8-bit. It might be 16-bit or 32-bit, right? So these some specifications might change, but basic such building blocks will always be there. Now, when such components, whether accumulator register, right? Register is able to store the data, which is made of flip-flops, or addition, subtraction, there is arithmetic and logic unit, which is doing different operations. In the end, what we have? In the end, we have such ICs which are made of logic gates. And logic gates, they are made up of transistors. Most of the time, we have ICs which are CMOS technology. CMOS full form is complementary metal oxide semiconductor field effect transistor. In the course of basic electronics, we have learned this CMOS logic and how to make a NOT gate, how to make a AND gate, OR gate using these MOSFETs. These are those circuit connections. So using transistors, logic gates are made, and gates are then used to make different combinational and sequential circuits for a microprocessor. Now, our first unit, that is for data representation, right? Which data computer works on, and what is the need that data conversion is to be done. Just a second. Yes, so in real world, we might use different languages, different numbering systems, but how computer works, right? For real world also, we do not know all the possible languages. So for that, we need a translator who translates the language into the language which a person can perceive. Similarly, most of the times we use decimal number system in our daily life, but computers work on binary. So we need a decimal to binary converter, decimal to binary encoder to convert the number into binary. And these binary numbers are used by the computers. Computers understand only binary data, zeros and ones. Computer do not understand decimal number system. Computer do not understand radix 7 system, radix 5 system. Okay, just a second. Okay, students, all the students, I request you to download, you are on internet only, so download the architecture of not this Arduino, but download the architecture of 8085, Intel 8085 microprocessor. You need to download the architecture of 8085 microprocessor and study the architectural component for this. I give you 10 minutes for this and you need to do this right now. All the students download 8085 architecture. You need to study this architecture. I give you 10 minutes for this. After that, I will ask you questions. So stay on the line and do this task. This is an in-class activity which is assigned to you. And this is must for all. You have got 10 minutes for this. Okay? And no discussion. Only you have to do this. 10 minutes. Okay, students, let us see one by one what you have done. Starting with Krishna Singh. Krishna, you can unmute your mic and answer. Krishna, are you with me? Krishna Singh, are you with me? Yes. Then you can unmute your mic and reply what blocks you are observing into the architecture of 8085. Krishna, you can unmute your mic and reply. Okay, Brajesh. Krishna, whenever I ask any question, you need
Yes,
to
sir.
reply. If you are not replying, I will be considering as you are absent.
Yes, sir. Yes, sir.
Yes, Brajesh. What are the architectural component in the 8085 architecture that you are
Sir,
talking?
sir, basically, sir, mainly use ALU and timing and control unit and instruction register and decoder and register
Okay.
array
Okay.
and interpreter controller and serial input, output and controller.
Okay. 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 Good. Good. Then Karthik Patel. Karthik Patel, are you with me? Yes. You can unmute your mic and reply. What is your observation regarding architectural components?
Yes, sir. Mm, Sir, there are intercontrol, serial output input control, 8-bit internal data bus, multiplexer, stack pointer, program counter, add buffer 8-bit, data address buffer 8-bit, time timing and control unit, arithmetic and logic unit, instruction register.
Okay. Okay. Good. 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 So now let us move forward. That what computers understand. Okay. And why do we need a conversion of data numbers into a binary form? Because whether it is text or video or image or numbers, anything, computer understands only the binary. So whether it is a number in real life or whether it is image in real life or whether it is video, whether it is text, any of this information, finally it is stored in computer in a binary format. Now, when we learn about binary format, we need to understand regarding the number systems. There are, for this course, we can consider 4 different number systems. One is a decimal, that is normally we use in our daily life, that is radix 10 base system. In the radix 10 base system, the numbers are between 0 to 9. If it is radix 10, that means the numbers are 10 minus 1. The largest digit will be 10 minus 1. So radix 10 system has starting with 0, largest digit 9. Similarly, binary, which is radix 2 system, it is radix 2. So the largest number will be 2 minus 1, that is 1. So we have numbers starting with 0 up to 1. Only two numbers in the binary system. Then there is an octal system. In the octal system, this is a radix 8 system. Radix 8 system has 8 minus 1, that is 7. Numbers starting with 0 up to 7. Octal system has only 8 digits starting with 0 up to 7. Hexadecimal system, that is radix 16. This has largest number 16 minus 1, that is 15. But 15 we say in decimal, right? In the hexadecimal, it is assigned a different symbol. So the number will start with 0, it will go up to 9, and then the number 10 is represented by A. Number 11 is represented by B, 12 by C, 13 by D, 14 by E, and 15 by F. So numbers are starting with 0 and goes up to F. 16 different digits in hexadecimal system. This plays very important role in the data representation. Now, what are the different basic rules we need to remember regarding arithmetic operations on numbers? For example, suppose when we add two binary number 0 and 0, summation results in 0 and the carry is 1. Sorry, carry is 0. 0 plus 1, summation is 1 and carry is 0. 1 plus 0, summation is 1, carry is 0. And 1 plus 1, summation is 0, carry is 1. Now you consider our regular decimal system. In our regular decimal system, when we perform addition, suppose we add 1 plus 2, the answer is 3. Okay. Suppose we add 3 plus 4, the answer is 7. Okay. Suppose we add 8 plus 3. Right? In this case, the answer is 11. So here, the number 1 is having a decimal place of 10 raised to 0. And this number 1 is having decimal place of 10 raised to 1. So this we can consider carry. Right? So similarly, in the binary system, when we add two numbers 1 plus 1. Now 1 plus 1 is 2. How 2 is represented in binary? 2 is represented in binary as 1 0.
1 0.
Yes. Yes. So 0 is the sum which is having a position of 2 raised to 0. And 1 is considered carry which is having a position of 2 raised to 1. So this is radix 2 system, this is radix 10 system, right? Similarly, for subtraction, when we subtract 0 from 0, subtraction is 0, borrow is 0. When we subtract 1, when we subtract 0 from 1, then subtraction result is 1 and borrow is 0. 1 minus 1, subtraction 0, we do not need a borrow. But only in the case of 0 minus 1, we will need a borrow. Okay. When we borrow, at that time what we get? We take a subtraction from 2 minus 1. Right? So from that, 1 is already there and 1 is the additional borrow. So the borrow is 1 and 1 minus 1 gives us subtraction 0. Then what about multiplication? 0 multiplied by 0 is 1. Anything multiplied with 0 is 0. Okay. 0 multiplied by 0 is 0. 0 into 1 that is 0. 1 into 0 is 0. 1 into 1 that is 1. Anything multiplied by 1 that is itself. But in the case of computers, we only have binary, only ones and zeros. So using this logic, digital arithmetic logic, and using the logic gates, different circuits are fabricated. They are used for construction of microprocessor. So some circuits are called as a combinational circuits. Combinational circuits are those circuits whose present output depends on present inputs only. For example, let us see this. This is a landing gear warning system. How a logic circuit can be designed for the aircraft for this? There are landing gear sensors. There are logic levels which are set, that what is the existing level, 0 or 1. Gears are extended or gears are retracted, right? And then there is a pilot who is giving signal. Yeah. All three combined, taking a data of landing gear sensor with the existing value, whether gear is retracted or extended, and the instruction by the pilot. Now here we have used the NOR gate. NOR gate will give output 0 only and only when all three inputs are 1. Yes or no?
Yes, sir.
So when all three inputs are 1, then output will be 0. In that case, over here we will have 0 volt. Here we have connected LED whose anode is connected with plus V volt. So anode voltage here, if it is the voltage is 0, then there will be a voltage difference, anode to cathode voltage difference. LED will be in forward bias and it will emit light, which will indicate gear is retracted. So when gear is retracted, this logic, right? Logic 1 is our input, and other inputs are also 1. Then and then only LED will give indication that gear is retracted. That is our warning system. Similarly, when gear is extended, in that case, what is done? Here, AND gate is used, but before AND gate, there are NOT gates, 3 NOT gates. So if here gears are already extended, then at this line the output will be 0. Output will be 0. Okay. Sensors will also give output will be 0 if the gears are extended. And then there is an additional instruction from pilot. If all three inputs are 0, then NOT gate will make it 1 as an input to the AND gate. And when all three inputs are 1 to the AND gate, the AND gate output will be logic 1. Logic 1 meaning, let us say, plus 5 volt. So it will create here LED is connected, cathode is connected to ground, anode is connected, will get some 5 volt, so LED will emit, indicating that gears are extended. So this is a circuit whose output depends on present inputs only. Sensor data is an input, logic levels which are set, and signal coming from the pilot. Similarly, another example, let us say we have a storage tank monitor circuit, which indicates that the storage is having low level. So over here we have deployed sensors at the bottom of the water tanks, and sensor's output are fed to logic gates. Now, this logic gate, gate G3, has two inputs. One is from C and second is from B. G2 has two inputs. One is from C, second is from A. And G1 has two inputs. One is from A and second is from B. All these gates will give output 1 only when both inputs to the gate are 1. Otherwise, it will give output 0 only. If any of the input is 0, then output will be 0. And so output of these 3 AND gate will be 1 only when 2 out of 3 tanks are empty, meaning sensor is giving signal logic 1 when the tanks are empty. And here we have used OR gate, 3 input OR gate. What it will do, if any of this is logic 1, then output will be logic 1. So it will give an indicator. We can put a LED over here. That will indicate 2 out of 3 tank is empty. Clear? So for this circuit also, present output, the indicator light, depends on present state of inputs only, that is coming out from the sensor. But then there are certain circuits which are sequential circuits, where the output of the circuit do not depend just on the present input, but it also depends on the previous state input or output. Like you see, in our daily life, we see this traffic light. Suppose it is said that every 30 seconds it has to change. So for 30 seconds it will be red, then from some 5 seconds it will be yellow, and then another 30 seconds it will be green. Then another 5 seconds yellow, and then again red. This is the logic that we have set. So when we design this algorithm, the algorithm will need a counter circuit, a counter IC, to calculate how many clock cycles have happened. We need additional clock circuit to generate a reference clock. Then we set up a counter circuit which changes its value at every 1 second. And then we need to design a logic which will generate 3 different signals depending on what is the previous result, right? Suppose in the present state of the system, there is a red light on, right? So we need a counter to calculate that up till 30 seconds, the red light should be on. And then for 5 seconds to yellow. And then we need a memory to store that the previous state was red, not green. So previous state was red. So after 5 seconds of yellow, we will have 30 seconds of green. So to take that decision, that algorithm has to go for generating output green signal. It has to remember that previous signal is red, right? So here the present input also requires previous results. Similarly, you see in the vending machines, right? The machine will need to keep track that how many packets are there inside. So, suppose there are 10 packets of chocolates, and someone orders 1 chocolate, then it will need to remember that now only 9 chocolates are present. Then in the second transaction, someone orders, let us say, 5 chocolates. So now it is only 4. Right? Once suppose all 10 chocolates are empty, then vending machine has to remember that any new request for the chocolates should not be accepted because it is empty. Already the counter is change from 10 to 0. Just a second. Okay, yes, students. So the vending machine requires such logic. Then the conveyor belt system requires this logic, right? Suppose there are 1,000 pieces to be drilled. So now the counter has to make sure that how many pieces are drilled. And it also needs a track of this distance between two objects, and that is tracked by the sensor. That is a different thing, but I hope I have made it clear. Yes or no?
Yes, sir.
Yes,
Okay.
sir.
Now for such application, to design such systems which are based on memory, we need a memory, and memories are made from flip-flops. See, SR flip-flop, JK flip-flop, D flip-flop, T flip-flop. So flip-flop is a basic memory element which is having only two state, either 1 or 0. Okay, and that is why the name is flip-flop, that it can have only two values, either 1 or 0. Now what will be its value? That is dependent on the what inputs we are giving to the flip-flop. As well as, suppose there is SR flip-flop, okay? SR, S means set and R means reset. So when set signal is given, the flip-flop will store a value 1. Set and reset, both signals cannot be given simultaneously. Only one signal at a time. And that is with reference to clock. Now flip-flop will trigger its value. The flip-flop will update its value only and only when the clock is triggered. Okay. Now, have you heard this concept of triggering before? Triggering of clock, there is a level triggering, age triggering.
No, sir.
See, the clock signal, that will be this kind of signal, right? And that is continuously generated by the crystal. So if the circuit itself is, let us say, it is level triggered, that means all the sequential components will take a decision only when certain level of the clock is reached. In the level triggering also, there are two things, either logic 1 level triggering or logic 0 level triggering. Logic high level triggering, logic low level triggering. So in the logic high level triggering, only in the time duration when the clock is having a value of plus V, in those time duration only, clock will, the flip-flop will update its value based on inputs. Whatever is the input, okay? Inputs, suppose set and reset, any input is applied, but flip-flop will not update its value anytime as soon as the signal is applied. Flip-flop will update its value when the triggering happens. And here, triggering concept, if it is chosen to be logic high level triggering, then what it means that flip-flop will update its input value only when the clock signal is logic high. Is that clear?
Yes,
Is that
sir.
clear? Okay. Similarly, there are other types of triggering also, like logic 0 level triggering. So in that case, flip-flop will update its value when clock signal is logic 0 in this time duration only. Then, now most of the times flip-flops are not level triggered. Remember this. Latch are level triggered, but flip-flops are not level triggered. Flip-flops are edge triggered. So whenever there are two edges, one is edges which is showing a transition from 0 to 1. So that edge we call as a rising edge. And another edge which is showing a transition from 1 to 0, that edge we call as a falling edge. Rising edge and falling edge. So two kinds of triggering is possible. One system, one digital IC will be fabricated based on any one of these. Okay? Suppose it is rising edge triggering. What it means? The flip-flop will take decision of updating its value only when there is a rising edge on the clock signal. In the remaining duration, flip-flop will not update its stored value. It will wait for the next clock cycle till there is a new rising edge. When there is a new rising edge, flip-flop will check what is the status of input. Depending on the status of input, it will update or not update its stored value. तो जो ट्रिगरिंग का कंसेप्ट है फ्लिप फ्लॉप के साथ में मोस्टली एज ट्रिगरिंग होता है. राइजिंग एज या फॉलिंग एज आईसीज अलग अलग टाइप के मार्केट में मिलते हैं. अब यदि राइजिंग एज ट्रिगरिंग है तो फ्लिप फ्लॉप अपना स्टोर्ड वैल्यू अपडेट करने का डिसीजन कब लेगा? जब क्लॉक साइकिल में राइजिंग एज आएगा तभी. अदरवाइज यदि राइजिंग एज क्लॉक साइकिल में नहीं है तो फ्लिप फ्लॉप का जो स्टोर्ड वैल्यू है वो एज इट इज रहता है, उसको चेंज नहीं होगा. फिर जो भी इनपुट हो, स्टोर्ड वैल्यू अपडेट कब हो सकता है? जब नेक्स्ट राइजिंग एज आए उस टाइम इंस्टेंट के ऊपर. इज दैट क्लियर?
Yes, sir.
So flip-flops, and there are different types of flip-flops which you might have studied in the course of digital electronics. SR flip-flop, JK flip-flop, D flip-flop, T flip-flop. Now you see, normally the number systems that are generally in use on our daily lives, that is a decimal system, because that is what we humans, Homo sapiens, we are all familiar with. Why we are most familiar with decimal number system? Because we have 10 fingers, right? And that is used to do calculations, 1 2 3, right? But the computers, the numbers are represented by a sequence of bits, ones and zeros. So that will understand only 1 and 0. We can have an analogy with a switch, 1 or 0, on or off. This is what is used by computers. Okay, now all of you know this. So let us see one by one. What is the working of AND gate? Who will tell me?
Sir, me.
Okay, Brajesh. Starting with the AND gate first.
सर एंड गेट मेनली यूज होता है सर दो बाइनरी नंबर को मल्टीप्लाई करने यानी उसका प्रोडक्ट निकालने के लिए यूज होता है. जैसे कि कोई दो बाइनरी नंबर है, जैसे कि 0 0, तो उसका जो प्रोडक्ट होगा वो 0 होगा. इसी तरह से सर यूज होता है मेनली सर्किट में.
ओके, एक मैं यहाँ पर आपका करेक्शन कर दूं. ये जो ऑपरेशंस है वो लॉजिकल ऑपरेशंस है, ये अरिथमेटिक ऑपरेशन नहीं है. सो this is not multiplication. Yes, the gates can be used to design a multiplier circuit. ओके, गेट का यूज मल्टीप्लायर सर्किट डिजाइन करने के लिए हो सकता है, लेकिन वो खुद मल्टीप्लिकेशन नहीं करते हैं, वो खुद एक गेट एक लॉजिकल ऑपरेशन करता है. तो जो एंड गेट है उसका ऑपरेशन क्या रहता है? इफ बोथ इनपुट्स आर 1 देन एंड देन ओनली आउटपुट इज 1. एंड लॉजिक in our real life also, when we have AND logics, suppose दो बस आ रही है, दो बस आने के बाद ही तीसरी बस निकलेगी, तो ये क्या हुआ? ये जब तक दोनों बस नहीं आ जाती तब तक तीसरी बस निकलेगी नहीं, तो वो AND लॉजिक है. सो व्हेन टू इनपुट्स आर 1, यहां पर टाइम डिले नहीं होगा, एक साथ दोनों इनपुट आएंगे. एट अ टाइम व्हेन टू इनपुट्स आर 1, then and then only output is 1, otherwise output is 0. That is AND logic. ऐसा हम एक सिस्टम भी डिजाइन कर सकते हैं सीधे हमारे होम ऑटोमेशन के लिए. सपोज आपने डोर के ऊपर सेंसर रखा है, विंडो के ऊपर सेंसर रखा है, तो और एसी आपको ऑन करना है, तो मेक श्योर के सारे एक रूम में एक ही डोर है और एक ही विंडो है, तो वहां पर दोनों सेंसर रखे हुए हैं. दोनों सेंसर यदि लॉजिक आउटपुट 1 देते हैं, मतलब डोर और विंडो दोनों क्लोज है, तभी एसी ऑन करो, तो ये एंड लॉजिक हुआ, राइट? इफ टू इनपुट्स आर 1 देन एंड देन ओनली आउटपुट इज 1. देन देयर इज OR लॉजिक. इन OR लॉजिक what it means, if any of the input is 1, then output is 1. Not logic. It is complementing the, not logic, it is complementing the input value. If input is 0, then output is 1. If input is 1, then output is 0. Then there is a NOR logic. NOR, you see, the output is invert of OR. What is OR logic? If any input is 1, then output is 1. What is NOR logic? If any input is 1, then output is 0. Now suppose I tell you to design a logic which gives output 1 when all the inputs are absent. Otherwise output should be 0. That is NOR logic only. If inputs are 0, inputs are false, inputs are absent, both inputs, all inputs, then output is 1. Otherwise output is 0. NAND logic is complement of output of AND operation. What is the AND operation? Output is 1 only when both inputs are 1. So what happens in NAND? Output is 0 only when both inputs are 1. When both inputs are 1, then and then only output is 0. Otherwise output is 1. And then XOR logic gate. Here, if inputs are unequal, if inputs are not same, then output is 1. But if inputs are same, then output is 0. XNOR symbol. What it does? If inputs are equal, 0, 0 or 1, 1, then output is logic 1. If inputs are unequal, then output is 0. XNOR gate is also called as equivalence gate. If inputs are equal, then output is 1. Okay, so this is your revision for the course of digital electronics. So far, are you with me? Any doubts in this?
No, sir.
No, sir.
No, sir.
Okay. Now addition we have seen already. So I'm just skipping this slide. We have seen addition, subtraction both. So we have types of number system: binary, octal, decimal, and hexadecimal. You always remember that the radix R indicates which is the number system. If R is equals to 10, then it is decimal. R is equals to 2, it's binary. R is equals to 8, it is octal. R is equals to 16, it is hexadecimal. So if it is radix R system, the number of digits will be 0 to R minus 1. Now, in our daily life, we use decimal systems, computer use binary. So why do we need to learn octal and hexadecimal? Why octal and hexadecimal is important?
क्योंकि सर बाइनरी में कोई बड़ा कोड होगा उसको सॉर्ट करने के लिए हम लोग यूज करते हैं octadecimal.
Yes, binary to octal and binary to hexadecimal conversion is very easy and it is directly visible. And so when there are long binary numbers which are difficult for us humans to remember, like this 100 100 101 011 0100 101 01 010, it is difficult for us to remember, right? So for that, if there is octal representation or hexadecimal representation, it will shorten the number and it makes us easy to remember. So the same number in the decimal is 6009 06785, and octal is 44532252. Its hexadecimal is 92A54. So hexadecimal, because it is its radix is larger, and so number is having less number of digits. So all the possibilities are there. We can convert decimal to octal, decimal to hexadecimal, decimal to binary, and reverse is also possible. So why this conversion are important? Because for digital hardware, the natural numbering system is binary, but for expressing anything in binary causes way too many bits to be used, and so it is not practical. And then there are numerous codes which are used, like hexadecimal, octal, and then there are other codes also, okay? Not just these two. There is a BCD code, access 3 code, gray code, error correcting code, ASCII codes, which are used to represent binary. Okay. Have you learned this code in digital electronics course? Gray code, access 3 code?
Yes, sir.
Yes, sir.
Yes, sir.
So you see,
Yes,
this
sir.
is the example of gray code. What is the idea?
Sir, we apply JOR gate to next digit.
Okay.
Sir, having one bit difference, sir.
Yes, having one bit difference between what?
Between sir,
सर
between
टू
given
पेयर के सर दो पेयर के बीच 1 बीट का चेंज आता है सर.
पैर, लेकिन सक्सेसिव पैर होना चाहिए.
यस सर.
1 और 2, 0 और 1, वो सक्सेसिव हुए. Right? So between any two successive numbers, there should be only 1 bit change. Right? So that is the idea of gray code. Then there is a BCD code. It is called as a binary coded decimal. And there is a ASCII code. ASCII code is used in our keyboards of computer, where letter A, it can be written by 0100 0001. So when you type A from your keyboard, what computer receives? Computer receives 0100 0001. There is access 3 code. So you see, this is 2-digit binary numbers, okay? There are 4 possibilities. 0, 0, 0, 1, 1, 0, and 1, 1. Between two successive numbers, that is 0, 1, 0, 0, then 1 bit change, 0, 1, then 1 bit change, 1, 0, then 1 bit change, 1, 1, 1, and then 1, 0. Okay. So between two successive numbers, there should be only 1 bit change. So after 0, 1, it is not 1, 0, because 0, 1 to 1, 0 will be 2 bit change. And so MSB is changed from 0 to 1, we have 1, 1. And now over here, number which is not used, LSB, that is changed, it is 0. This is gray code for 0, 1, 2, 3. You can see if there is one digit like this, in binary it is something like this. What happens in gray? If first digit is 1, then it is used as it is. Now second digit, there is XORing, so there is needs to be changed. Then XORing, because input is 1, so 0, and already previous was 1, so 1 XOR 1, that is 0. 1 XOR 0, that is 1. 0 XOR 1, that is 1. This is how gray code is generated. Again repeating, input is 1, 1, 1, 0, 1. So first 1 as it is. Then B1 and B2 XORing, that is G2. B2 and B3 XORing, that is G3. B3 and B4 XORing, that is G4. And B4 and B5 XORing, that is G5. So this is the logic circuit for it. G1 is same as B1. B1 and B2 XORing, we have used XOR gate. The output is G2. Then B2 and B3 XORing, output is G3. B3 and B4 XORing, output is G4. Okay. Now there are other codes also that we will discuss in our next lecture. So we have reached to slide number 27. Now feel free to ask. This meeting is open for questions. Feel free to ask if you have any questions. Students. Students, anyone? Any doubts or questions regarding the topics that we have discussed? Okay, no doubts? Then I request you to write your attendance in the chat box, and then we can end this session. Do not forget to write your attendance. And make sure that you check your attendance at the end of the day near 6 p.m. whether attendance is okay or not in our app.
Hello, sir. Hello.
Yes.
Sir, we have to write enrollment number or institute roll number, sir.
Write your enrollment number.
Okay, sir.